Okay, class, this is the beginning of chapter 14, 14A, and the purpose of this video is just an introduction to graphing the functions sine and cosine. So again, this is very introductory just to kind of get in that frame of mind. So let's take a look here. These are the two functions that you want to be graphing. And again, I can write these as, f of x is equal to sine of x, and f of x is equal to cosine x. So function notation as well. Now, what we want to notice is we're very used to the unit circle, and on the unit circle, you have an ordered pair of cosine sine. Okay, so this is what we have seen on the unit circle. So you would have like an ordered pair of like the square root of 3 divided by 2 comma 1/2. Okay. Now, notice this is we're not graphing the unit circle. What we're doing is graphing the function of sine. So we have an input of x, there's your input, and your output, which is the function of x or y. Okay, and we have to establish what are the x and y in these cases. Well, we have a different order pair. Okay, and again, we're not going to be looking at this. We're going to use this information, but we're not going to write it as an order pair in respect to the unit circle. What we're going to do instead is we're going to say, okay, what is the input of sine of x? You were inputting an angle, okay? And then out comes the sine function or the vertical function, okay? So I'm going to put vertical, just as a reminder. So our new xy, so for instance, where we have a sine of the square root of 3 over 2, and a cosine of square root of 3 over 2, and a sine of 1/2, well, where does this work at? Well, this works at 30 degrees or pi over 6, okay? Either one. Now, again, most of our graphs are going to be in this function of radians, so we want to use that. So my input is pi over 6. And my output is what is the sine value at that angle. Well, in this case, 1/2. So this is what we're shooting for. Input, angle, output, vertical dimension, or sine value. Okay, and likewise, cosine's the same thing where you have an input of the angle, but then the output is just the horizontal dimension or the cosine of that angle. So I'm just going to make a note here. The output here is the horizontal. Okay. All right, so let's take a look here at the graph. So this is what the graph looks like. Well, again, here's this reference to the unit circle. So what I was just talking about this last slide is this point right here, pi over 6 square root of 3 over 2 comma 1/2. So again, here's our input of 30 degrees or pi over 6, and then our output is 1/2. So let's take a look at the graph. Now notice here on the horizontal dimension right here, we have basically your angles, and then your vertical dimension is your output, which is the actual value. Okay, and if we're talking about sine, it's going to be the vertical, cosine, horizontal. So notice here we have pi, 2 pi. So this is 180 degrees, that's 360. So from 0 to 2 pi is basically one rotation of the unit circle. So let's kind of go through and just kind of talk about basic inputs. So if you think about what's the sine of 0 degrees? Well, the sine of 0 degrees is going to be 0. What's the sine of 90 degrees? Well, in this case, radians is pi over 2. Well, the sine of pi over 2 is at the top of the unit circle, so that's simply 1. What's the sine of pi? Well, we're back down at 0. What's the sine of 3/2 pi? That's in between, at the 270 at the bottom of the unit circle. We're going to be at -1. So basically what we're doing, and then back at 2 pi, we're back at the beginning of the circle, and there we go again. So what we're basically doing is taking a circular graphing rotation around the unit circle, and we're stretching it out into a horizontal graph, okay, where you have an x and y axis of input and output. Okay, now let's go put some secondary points in, and let's talk about what we have here. Now notice I have 12 square here, so every box is 1/12 pi. Okay, so if I go around pi over 6, that means I'm going to go 2/12 pi, 2 boxes, and I go up to 1/2. Okay. If I go pi over 4, which is 3 boxes, 3/12 pi, and I say, okay, what's the square root of 2 over 2? That's somewhere around 0.71-ish, I believe. So I'm going to go right up to just below 3/4, so put a dot. And then I'm going to go over to 4 boxes, which is 1/3 pi, and say square root of 3 over 2 comes around, I believe, somewhere around 0.86. It could be a little bit off there, but I assume it's around 0.8 something. I think it's 0.86. So we'll put a dot right here. Now notice when we get into second quadrants, we have the exact same thing, just mirror image. So I'm going to put those dots in respectively. And then we get to see the same thing over here. Dot, dot, dot. And again, it doesn't form a line. It's forming a gradual curve here. And notice we have rotation. So what I'm going to do now is draw a line connecting all these points. And what we have here, this is called one cycle or one period. And the period starts at 0 and it goes all the way to 2 pi. Okay, so this is called a period, and we're going to see this a little bit in our next lesson as well. And notice when we get to 2 pi, we simply start over again, and let's do it in a different color. But if I see my curve goes up to 90 degrees, I'm simply going to go up and do the same rotation. Likewise over here, I can go this way as well and start to see this rotation, and off we go in that direction as well. Okay, so the red part is simply just one cycle, one rotation. Now again, let's graph cosine on this x-and graph. I'm going to graph it all in blue here now. The only difference is cosine. What's the cosine of 0 degrees? Well, it starts at 1, and then when you get to pi over 2, you're just simply going to be back at 0. And then when you're at pi, you're going to be at -1. And then at 3/4 pi, or 3/2 pi, we're back at 0. And then at 2 pi, we're back at 1 again. Okay. So notice here, it's the exact same curve, but this time it's offset. That's pretty horrible. I'm going to draw that again. Sorry about that. And we're going to just curve through. Notice it's not like a nice straight line. It's a nice flowy curve that gradually goes through those points. Notice it's the exact same curve except for it's shifted. Okay. And, you know, how much is it shifted? Well, basically pi over 2 or 90 degrees, because we talk about, you know, between sine and cosine of the angles in a triangle, well, they're basically complementary. Okay. I'm going to show you a website right here, and I'll post this on Blackboard as well. But what we see here is the unit circle up top, and we see a sine graph down here. So notice we're in sine. You can see the xy value over here, and you can show the function. So they're going to input the angle. Now again, they're putting it as a decimal here because the computer here doesn't understand radians, you know, in terms of pi, but it'll be as a decimal, and you'll see the output. So I'm at 0 right here, the green dot, and as I move this up, let's kind of put it at pi over 6 or 30 degrees. You see our vertical dimension here in red, and you can see the vertical dimension here is red. So we rotated 30 degrees, or pi over 6, so I moved horizontally, but then my output, my sine value is right here. So you notice as I go through the circle, we go around the circle, and we come back to the horizontal axis again, and we go around again. Now notice this time on my second rotation, so I'm beyond 2 pi, and I'm now going towards 3 pi. So it's a graph that goes on forever. It keeps going on and on and on. Okay. Now we can see the same thing in cosine. Is simply just hit that button, and it goes. We start a cosine. So I'm gonna reset it, and we're gonna start here, and we're gonna go up, and we can see the cosine value. So notice on the unit circle, we have a horizontal dimension, so in this case it's 4 boxes long, and we can see that's going up 4 boxes high. Okay, so it's graphing the horizontal displacement of the unit circle. So again, we just go all the way around, and we can see one rotation. Okay, so this is a nice graph that shows the relationship between a unit circle and the sine function and cosine function in real time. Okay. All right, so that's really all this video shows, is just introductory to the functions of sine and cosine.